In Chapter 2, we're going to be learning about some of the fundamental concepts of arithmetic, but we're going to start with sets, the idea of sets. And a set is simply a collection of objects. Doesn't even need to contain numbers. You could have a set of your favorite pizza toppings. It's just a collection of objects. These objects are called elements or members of the set. And you will hear me use those terms interchangeably. So for instance, I could have a set, and I'll call it set P for my pets. I actually have 3 cats. One is named Tiger, one is named Sammy, and one is Frankie. So each of those pets, each of my cats, is an element or a member of the set of my pets. Now, all of the objects that are considered for a set make up the universe. So in the case of pets, the universe would be all of the pets in the whole state or country or planet. And then the set are my pets, okay? When we talk about sets, a lot of times we're going to use braces to represent a set. And really the default, if you see braces, you want to think set. But you could also write out the set in words. You could describe it in words, like I have here, the set of the first 3 presidents of the United States. Okay, that's just a word description. Like I said, the braces are the most common, and you can also see set builder notation. And the way set builder notation reads, this is the set of all x such that, that's the vertical bar, such that x is one of the first 3 presidents of the United States. And a lot of times when you get into the higher level math classes, you'll see that set builder notation more often. In here, we'll mostly be using the braces though. Typically, sets are written with a capital letter. And to show that something is a member of the set, we use this symbol that looks kind of like a backwards E. That indicates that something is a member of a set. So I could say, if I'm looking at my pets, let me write it over to the side, I could say that Tiger is a member of set P. That's the notation. To show that something is not a member of the set, it's that symbol just with that slash mark through it. So that indicates it is not a member. Now, when we're talking about numbers, our most basic set of natural numbers are the counting numbers or the natural numbers. This is what you teach young children as they're first learning to count. 1, 2, 3, 4. In the natural numbers, there's no 0. There's no negatives. There's no fractions or decimals. It is just your basic counting numbers. And then we're going to build our number system from that. But I'm going to actually walk away from that for just a moment for this first example here. It says, write the following set. Part A, the set of letters used in the sentence list the elements in a set only once. When you're writing out a set, there's 2 things that are important. 1, you don't need to repeat things. So for instance, in this sentence, the letter L comes up multiple times, but when I'm dealing with it in a set, I only need to write it once. The other thing is that order does not matter. I will be honest, if I was writing this out, let's say a little more formally, I would probably put it in an alphabetical order just because that's what we're used to seeing. But order does not matter. So those are the 2 important things when you're dealing with sets. You only need to write things once. You don't need to duplicate things. And also, order does not matter. If you hear any crazy noises in the background, Two of my cats, they're almost on cue today, have decided to be crazy men this morning. Okay, so there's all the letters and list the elements in a set only once, okay? And again, you could put them in alphabetical order if you wanted to. Order does not matter, and again, they don't need to be, you don't need to repeat letters. So that's also highlighted in Part B, the set of letters that are needed to spell these 4 words: team, meet, mate, and tame. All 4 of those words are written with the same 4 letters. So this is a much smaller group of letters, so I will do these alphabetically. So the only letters that you need for those 4 words are A, E, M, and T. And by the way, I'm writing these with capital letters. You could to write the letters in the sets with lowercase letters as well. I just did capital letters, so there's no confusing as to what letters I'm writing. And then one third thing about sets is we're going to see here in Part C, the set of states in the U.S. that contain the letter Q. Well, you can think about it for a minute. You can consult a map, but there are no states in the United States with the letter Q in their name. So what we do is we write an empty set. So literally a set with nothing in it. You might also see this symbol, which means the null set. Okay, that's our empty set, or the null set. It means there's nothing there. There are no states in the US that contain the letter Q. Now, I said I was going to leave numbers for just a minute and then come back to them. And I want to look at one more example on this page where we are going to be using some natural or counting numbers. Specifically, we're going to focus on the numbers from 1 through 20. So this is our universe. That's what the U represents. In this case, we are only considering the numbers from 1 through 20. You'll note here we have the ellipses. Ellipses right there. That's just so we don't have to write out every single number in this set. People understand 1, 2, 3 up through 20 means 4, 5, 6 up through 19 are all included. They're just not written out. So we're going to answer 3 questions. First one says, write the following sets by listing the elements and braces. So we want all of the numbers x in the universe such that x is divisible by 4. So we're looking for the multiples of 4. So the numbers just from 1 through 20, the numbers that are divisible by 4 are going to be 4, 8, 12, 16, and 20. And again, order does not matter. With letters, a lot of times you might see them alphabetically. With numbers, a lot of times we write them from smallest to largest just because that's more natural to us, but you don't have to. This set would have been the exact same set had you written 20, 8, 16, 4, 12. As long as you have those 5 numbers, you are good. Part B, we're looking at all the numbers from the universe such that the number is odd and it is between and including 9 and 13. So we want our odd numbers from 9 through 13. This is a very small set here. We're just looking 9 through 13. The odd numbers are 9, 11, and 13. And the last one, we're looking for numbers in the set such that the number is a perfect square. So x is n squared for some n in the set of natural numbers. So just to read this one. So x is part of the universe, which we've defined up here, such that x equals n squared. That means it's a perfect square for some n in the set of natural numbers. So whenever you see this capital N, that is referring to those natural numbers. So what are our perfect squares from 1 through 20? 1, because it's equal to 1 squared. 4, because it's 2 squared. 9, 3 squared. And then 16 is 4 squared. 5 squared is 25, so we're out of our set U. So that's some basics on sets. We're going to continue in the next couple videos to talk about sets and what we can do with them.